you're asked to evaluate this double integral, right? It's the integral from 1 to 4 of the integral from 0 to the square root of y of e to the x over square root of y dx dy. So, I want you to pause the video, write it down, and work it out for me. Okay, have you finished? Let's see what happened here. Now, let's concentrate on this part, the inside integral. Alright? So we're going to integrate from 1 to 4 of something dy. Now let's concentrate here. Now, you integrate from 0 to the square root of y e to the x over the square root of y dx. So x will be the variable. You treat y as a constant for now. Now, use the chain rule. Alright? You could consider this as the integral from 0 to the square root of y of e to the x times 1 over the square root of y dx. This is just some constant, like some number. Right? Now, generally, if you have y is equal to e to the ax, and you let u be equal to ax, now you finding the integral of y, or the integral of e to the ax dx. That means x is a variable, is just a number. And here, du by dx is equal to a, right? So dx, no, alright, that bad part bad. So dx would be equal to du over a. Just a reminder here, integration by substitution. So you have the integral of u, because u is, e to the u, because u is ax, dx. But what is dx? You want integral of a function of u du, not dx. Right? So, but dx is du over a. And a is a number. So, when you integrate e to the u, you get e to the u. So, so this is going to be, well, this is really the integral of 1 over a e to the u du. Well, I write this like that. It's du. Alright? E to the u du. 1 over a times e to the u du. Which is 1 over a times e to the u. Well, what was u again? U was ax. So it's e to the ax. So, here now. You see the 1 over square root of y? That's like the a. So what you're going to get when you perform, let me just cover this, it's rough work. It's reminding you of something. What are you going to get when you do this integral? Going to be integral from 0 to, well, let's do the integral. It's going to be e to the x by 1 over square root of y divided by the constant there, 1 over square root of y. Just like how e to the ax is 1 over a, e to the ax. Same thing as e to the ax over a, right? Same thing happens here. Alright. So, what you have when you integrate is e to the x over square root of x over square root of y, which I write here as x times 1 over square root of y, divided by 1 over square root of y. And you're going from, to the boundaries again, 0 to square root of y. From 0 to the square root of y. But don't forget that you have this second derivative to work out, you know. Keep writing it or you might forget. Integral from 1 to 4 dy. Alright? Okay. So what happens here? Now, this is dx. You're integrating with respect to x, so y is just a constant. So you put in the upper boundary, square root of y for x. Let me write back the integral from 1 to 4 off. Alright, so it's e to the square root of y times 1 over square root of y over 1 over square root of y. Alright? Oh, let me put it this way. Minus. Then what's going to happen here is that you put in 0 for the thing there, for the x, the lower boundary. You just put in the upper boundary square root of y, so now you put in 0. So it's e to the 0 times 1 over square root of y over 1 over square root of y. Right? dy. You haven't started that integration dy yet, but you're working on dx. Integral from 1 to 4 off. Now square root of y cancels square root of y here. So it's e to the 1. Just e over 1 divided by square root of y. Alright? Minus e to the 0 is 1. 1 over 1 divided by square root of y. dy. Alright? Now, the thing is, you can rewrite this in a simpler manner. Alright? You can call this the integral from 1 to 4 of e square root of y minus square root of y. Fractions, right? You have to remember your fractions to deal with this part of things. Right? Now, after that, let me see something here just to make sure everything is okay. Derivative 1 over square root of y, that you differentiate, you integrate, so it's that over 1 over square root of y. Nice. You work that out, on and on. Okay. So, dy now. You ready to deal with it with respect to y? Alright? Let me see something. Okay. Dy. So you're ready to do this part now. Alright? What you have here, right? Y, the square root of y as y to a power. So it's integral from 1 to 4 of e times y to the half minus y to the half dy. Okay. So when you do the integration, it's e y to the half plus 1 over half plus 1 minus y to the half plus 1 over half plus 1. And you're going from 1 to 4. So this is e times y to the half plus 1 is 1 and a half. 1 and a half, 2, 1 to 1, 3. 3 over 2. 3 halves. Over 3 halves minus y to the 3 halves, 3 over 2, over 3 over 2, right? From 1 to 4. So what you have here now is you substitute for y e times 4 to the 3 halves. When you divide by 1 over 2, it's the same as 2/3. So it's 2/3 e times 4 to the 3 over 2 minus 2/3 4 to the 3 over 2. That's one part, the upper boundary, minus substitute the lower boundary now. It's going to be 2/3 e times, well, y is 1, so it's 1 to the 3 over 2 minus 2/3, y is 1, so times 1 to the 3 over 2. Alright, so what happens here? When you have a number raised to a fraction, the numerator at the top of the fraction gives you the power, and the denominator or the bottom of the fraction is the root. The square root of 4 is 2, and 2 to the 3 is 8. So this becomes 2 over 3 times 8e. Alright? But 2 8 is 16, so I can just write the 16 from now. Alright? Alright, so 16 minus, this is 8 to 8, 16 over 3 minus, you have, well, 1 to any power is just 1. So it's 2/3 e minus 2/3. Alright, so let's open the brackets and see if we can simplify. 16/3 e minus 16/3 minus 2/3 e plus 2/3. So you have 16 over 3 e minus 2 over 3 e minus 16 over 3 plus 2 over 3. 16 minus 2 is 14, so it's 14 over 3 e. What's negative 16 plus 2, that's negative 14, so it's minus 14 over 3. So it seems like what we get there, here now, is 14 over 3 e minus 1. Okay, so that's what we have, 14 over 3 e minus 1.